I'm so sorry.
Well, that's okay. No, thanks for letting us know. We'd like to have this to post and archive, so we are going for the best sound that we can.
Yes.
We are recording.
We are recording. Very good. Thank you. Ken Miller, turning it over to you.
Okay. I'm Ken Miller. Work with ESnet now. I was also part of my job is working with the EPOC team in Indiana, doing performance and engagement, troubleshooting, and also consulting, and trying to talk about different services like that, infrastructure reviews, things like that. So I'm going to start off, go into the two sections of the talk, and then we'll talk about services a little bit. There are some sections I'll skip over just to try to get to create more of a discussion with this once we go over some of the basic materials, and then from there we can kind of see where we go. So I'll start sharing and we'll see where we go from there.
Sounds good.
Thanks. So, does it look right?
Yep, looks great.
Okay, thanks. So what we're going to start out with is the data mobility exhibition. What we're looking to do here is just kind of do a general review of what was happened in the past and what some features we looked into. And this started a few years ago, looking at what was happening between different research services around the country. And one in particular was if with the climate science, and you're sending data over to NERSC for compute allocation. So some of these transfers were happening, and they were operating. They were just operating. They're up, they're working, things like that. But when you started actually paying attention to it, you saw the performance, you have on this chart here, see what the data set size is, the amount of files, and you saw the performances there, 13, 16, and 11 between the different facilities from the actual data share. When you started paying attention to it, what you kind of look at it from an infrastructure standpoint is what, as a regional provider, that's what you're going to look at. But what you really want to take a look at, try to put yourself in the researcher's shoes and see what's really happening there. What kind of performance are they getting? Or frankly, how long does it take to do their work? And everyone has the same amount of time every day. And, if we can actually try to make some efficiencies there, then, we can get more, hopefully more research done in that case. So the layout was really built on the Science DMZ model, looking at a research or resource that people were looking at and trying to get to some of the supercomputing facilities. And around, the performance goal is 15 gigabits a second to equal one petabyte. This data set is 4.4 terabytes to try to get through this. So when you break this down, here was kind of the baseline we started with and going through these data sets. And you see different sites were getting, sub 10, and some are a little bit over 10 gigabits a second in performance. Just observing this and stepping through these individual tests like this to see actually what's going on through your sites. The fact that, being a regional, you're in the middle of all this. So you actually have a great opportunity to really see and understand what data is going through your network, what researchers are doing at the edge, passing through you between different peers on your network, or as well as going to off campus or even off your regional network facilities and other research services. So then after looking at this and actually paying attention and doing a little bit of tuning on this, you see the numbers greatly increased, from before being, in the single digits up to, 10 to 11 up to 13, 16. You see here that you're approaching 23, 41, much faster than, it was before, with a little bit of tuning, a little bit paying attention. So, and again, the network is really the piece in the middle that's connecting all this. And so it's interesting to see, maybe the network's performing well, but the end hosts are not. So that's where the regionals play a vital role, is you have the ability to look at the infrastructure to see what's happening through your network, to see, hey, maybe there is a problem at the edge, or maybe there's a problem at the facility, or something's mistuned, things like that. So this is just an example of how, starting out with everything, looking at some baselines of, some elephant flows or from known research resources that you can get into, you can actually start, looking to see what else you can improve and really try to start scaling up some of these numbers for researchers. So the data mobility exhibition is really just a piece to baseline this, have a controlled endpoints that we know perform well from the previous example, and some other sites, as part of this project. And then you have known data sets, known services like that you're looking into to be able to pull the data down and see actually how well your infrastructure is handling it, whether it is something on your network or whether it's something passing through your network to an edge customer or to a resource that's downstream from your regional networks. So in going through this, one thing to step into is you really may not know what the research services are, the resources are, but since you are the network in between everything, you have, like I said, a great resource to really look into things and really engage your customers and engage the researchers as to what's going on, because it's passing through the regional networks. So this is one area where you can really play a vital role in looking at these services and then trying to understand really what's happening through the network without even really talking to anyone directly yet. You can really baseline a lot of these services and a lot of these, elephant flow or larger sites, or even larger, data transfers happening, even, before engaging anyone. On the other side of it, it also gives you the ability to discover who some of maybe your heavy hitters are, and some of these transfers that are below a certain threshold or a baseline you're looking at. So being the network in the middle really plays a vital role in this, because you have the data through the network to really see what's going on. Also, you see who it may be going to and from. So you have a great opportunity there. So the data mobility exhibition, like I said, was a baseline around this. This again is not a competition. We're not really out trying to, my regional's faster than your regional type thing. So, but from there, it's really just trying to, get a standard set of data, as well as some known endpoints that you can work from to get a good baseline out of this, and then do some performances, increases off of that. So I'll skip to here. So the reason where this comes into play is you have some resources really internationally all over the world. You might be trying to get data to and from, and whether it's a small site that's just on, a small field office to, a larger facility, getting data back to and from these campuses. And you have the national networks, but then the handoff to the regionals is really, really a vital piece in this. As we look at these pieces here, there are multiple networks that these transfers will traverse. And then looking into this, you can see that any kind of transfer problem may come up. You may have to contact, 1, 2, 5, numerous groups to try to troubleshoot some of these transfers and some of these other details around that. So if you take a different step to it, you kind of abstract the pieces out and looking at it from a data-centric or even a service-centric standpoint. The data is really trying to get from either where it's generated to where it's maybe even going to be stored, to where it's going to be computed, or even analyzed, or even presented, and then maybe even archived. So all these individual components of the data layer really get into some details around this, and that each one of those is an individual service that can be offered by a campus or potentially by a conglomerate or a regional we're looking at. The other piece of looking into it is breaking it down to individual components like this, that you can actually get into some of the other areas where, making this more of a modular approach as you're looking at these pieces. So, multiple researchers may be collaborating on the same data set across different of your connectors from a regional standpoint. The same data set might be being able to be downloaded twice. You might see that data twice on your network for that exact same reason. So from there, as it started last year, whenever we all still traveled, at the CC Star PI meeting and the Quilt meeting, the meeting that was Minnesota. So we had a workshop there just to kind of introduce this idea of, baselining of the transfers and discussing that, science DMZs are out there and they're playing a vital role in this, and as well as data transfer nodes and all these vital components to this. But one of the key factors was the data transfer speeds, including all this infrastructure. The data transfer speeds, were just a number that people were not baselining. They should have been with the reports, but sometimes the baselining wasn't happening before or after, or there really is no set, instruction manual on where these individuals need to be. So this data movement exhibition really kind of sets a standard for where the data transfer should be happening, as well as baselining that. So it was supposed to be finishing up after 1 year of this. With everything that's going on, we're going to extend it another year and actually try to do some extra, what we've learned so far this year. We'll go over that in a second, but some of the other pieces around this, we'd like to really dive into some other pieces that were infrastructure components and maybe some other workflows we're going to look at over the next year as well. So the original baseline set of data there with the original endpoints and the consistent data sets, the reference data sets, if you call them, they will be there, but there's a couple little things we're going to be looking into as well. So the idea around this is really just understanding what your data is doing, and how your infrastructure is performing. You kind of build a couple page description on your network, what you're looking into, maybe the data transfers you're trying, a little bit about your infrastructure, possibly how the data transfer node or how you're transferring data into your clusters or your storage, pieces like this. So a lot of your, from a regional standpoint, a lot of your customers may be doing this individually, but there might be an engagement or outreach opportunity to reach out to some of your constituents and some of your resources and connectors that you have to be able to offer this out there to see how well they're performing. If they have a future grant coming up, there's other ways to leverage regionals in this aspect, but this could be one case of there. The second, third bullet, I think, is look at the reference data sets and start pulling these data sets down. And you have the ability to write some of the data sets to certain locations as well. And then just kind of share your results. And then we're going to kind of take those results back and try to see what we learn out of this this exhibition and see what else we need to do to really try to step up the idea of the science DMZ and the data transfer nodes into like the next, what should we be doing next? What should the performance be? And really just kind of learn out of this from a community testing standpoint. So it's kind of the same thing here, what we talked about. So the current status is so far 665 tests have been completed, 41 individual sites have downloaded the test data, and 18 sites have uploaded the test data. This is taking out all the existing control sites that we know about. You see a variety of sites that are built into this. You see that some of the sites are used more often, and those are the reference sites, but you might see some of your other customers in here. I think Kansas is in here somewhere, GPN's on here. There's some of their sites that may be part of this. So this is a traffic sourced by the site, so downloading data from these sites. This is the idea of the destination sites where the traffic's going to. You can see there's kind of a breakdown of how many transfers have happened to this point. With that being said, I mentioned this before, there really is not a consistent reference point of what your data transfer should be, what speeds it should be. I mean, there's some expectations based on where they could be, but this is an opportunity to really understand what your data set or what your infrastructure is performing at, as well as the regional network. So far the transfers for some of these, I guess that I can kind of pass through these, but the average data set speed from the Cornell site is 2.55 gigabits a second as a source, and then the destination's a little bit faster. Boston's a little around the same. Actually, they're the same. I'll have to check those numbers. Sorry. At Michigan, the transfers here are 1.7, 1.75. The system at Argonne is running performing a little bit better as an average from the other sites. So 5 gigabits down and 9.5 gigabits average up. And then some of the other sites, the NCAR system is the one that's really has done the most testing from, and it's around 5.5 gigs in each direction. So that being said, I mean, we know these systems from the example before can perform very, very well. But this is something that, as a service standpoint and from a regional standpoint, you should see flows at least 5 gigabits a second, even on a 10 gigabit host. That's pretty common at this point. So if you're looking at your flow data, you're looking at some of your other traffic going to some of your sites, you should be seeing, it's single stream or multiple stream flows that are in the 5 gigabit range, either individually or combined. that standpoint. So they also, as part of this, we've enabled a couple writing endpoints to Cloud Drive, both with Google as well as Box. So you can see here that they are extremely throttled. So if you want to do some testing out to these sites from your campus, you can kind of see what kind of throughput you would get. But these sites just, any sort of cloud storage is usually pretty limited. So the other pieces we're looked at so far, the NCAR system is performing very well as a managed service. That's actually the reference point for a lot of this data transfers. Some of the individual sites, I think Kansas had a one node that was transferring at 24 gigabits a second. So, and then there was something down in South Africa that was transferring at 7.3 gigabits a second to NCAR. So that's, quite a long path, and it's really getting decent performance out of that. So some other sites around there, just a few of the state networks you see there mentioned, as well as some of the sites are pretty capable. Some could use some help, but again, we're trying this entire program to see what data transfer should be and try to get some reference points for, say, a 10 gig transfer node or a 25 or 40 gig transfer node, something like that, just so that people should be at these speeds, and so we can expect them, as well as the regional should be able to see these type of transfers happening through the network as well. So aside from that, we're trying to see what other kind of data we can get out of here, maybe including the speeds of the servers, so we can actually break those down a little bit better to try to get a detail of this. At the same time, understanding which the speeds were and how they're related to individual data, the reference data sets. So what kind of speeds are you getting based on a lot of small files versus a lot of large files? Those individual components, we'd like to break the data down a little bit further to get to that. So we're working to try to get some of that data out of there. A second piece here is for managed services as well, possibly from a regional, is what reference architectures do you, are being implemented at campuses or these larger facilities? And in doing so, maybe someone was sold a solution by a reseller or something like that, but how well is it performing? Are they just selling you a standard server? Are they actually selling you something high-end that will be able to handle this? This, again, is a platform that, as a regional, you can see the traffic going through your network, and an opportunity to engage one of your connectors to see really what speeds they're getting with some of these DTNs. So again, we can discuss this a little bit later if there's other information or other details you'd like to get out of this reference data set. So the next steps in here, we really want to focus on what, not so much the network, and the CC Star had a lot of 100 gig connections and individual pieces like that, and some regionals are turning out more and more 100 gig capabilities out there. But as you see from the reference data sets earlier, the average speeds are still under 10 gigabits a second. So, and that being the case, the last thing you want to do is have a campus, find some new performance tweak, and all of a sudden your regional is like, oh, very overwhelmed with the large data transfer. So in this case, this is something where you want to look at the usability, and we'd like to increase all these numbers. And that's the goal with all this, is to get the increase the speed. But some of these 100 gig, connections and things like that, the data transfer speeds aren't up to where we want to see them yet. So. So one expectation, another thing to set is on a 10 gigabit host with RAID, you should see at least 5 gigabits a second in that case. So that's something else that you might want to take a look at, is when you're looking at your regionals, do you see some of these flows and see what they're going through there, and see what kind of speeds they're running at. Another opportunity is a plug for another EPOC service or similar service. The NetSage piece looks at your traffic going to some of these regionals, and I think some of the regionals already have NetSage implemented. But again, this is a great way to really maybe just get an overall view across the regional perspective of really what traffic's being transferred. And then the last thing, I mentioned this a little bit earlier, a little bit alluding to it. The 100 gigabit connections really don't guarantee that you're going to get that kind of performance, unfortunately. So ESnet's actually only deploying a couple 40 gig nodes, right now. So for that exact reason, we focused on the reading and the writing of the data and the tuning of the server at 40 gig, just so we could maximize that as a resource. So all this aside, regional are, implementing more and more 100 gig, but you still should see, transfers in the 5 gigabit range on a 10 gig host, and on a 40 gigabit node, you should see, 25 gigabits a second, if not a little higher. So those are the kind of speeds you should be seeing on some of these larger flows on the science side of things. So, and the reference implementation here is a link, and here's some of the details about it if you look into this. And that server last year was around 21,000. So. So discussing this a little bit further and going into this, and we have a second piece of this in a little bit. So, I didn't really get a chance to look through the regional services spreadsheet you had. I looked through a couple components of that, but so since the network is already managed, what other services could be managed? Could you be managing the campus router and some of the BGP information? Could you be managing some of the campus firewalls, as a managed service? The measurement and monitoring, type of thing, the performance with like, persona, set up there. But when you break it down into all these components, the Science DMZ, it's typically just, as a simplest form could just be a 10 gig port off a managed router that a regional could provide. And that could be a managed Science DMZ, a managed router, and a managed data transfer node that regionals could provide as a turnkey service for this type of thing. Because a lot of times, as with a lot of these trainings, they're just, you can train the people, and then people might transfer jobs, or some of the systems may age out over time, or the expertise may not be focused on, and the performance may not be monitored over time. So as a regional perspective, there might be a way to break this down into individual components where regionals might be able to offer these Science DMZs as a service, as well as maybe a second port on a router could be connected to a single 10 gig server, and that would be all that a campus needs. There could be the potential of a larger data transfer node around a certain set of campuses that where the connectors may aggregate at some point, and you may have a shared data transfer node with shared storage directly off of that. So say you have 5 campuses looking at a large data transfer node that they want to buy into, but they don't want to buy it and manage it themselves. There could be a component there where you divide up the storage and divide up some of the services around that. So all these little pieces could be, since the regional network really is in the middle, these could be services that could be turnkey and adding value to just passing traffic type ideas. So breaking this down, this is kind of an eye chart, so I apologize. I'll send these out a little bit. This is really just looking at the CC Star Awards and where they were, and see what the breakdown of some of these components would be. So if you were to get a campus infrastructure award around 500,000, and if you were to life cycle that equipment on a 5-year basis, you're looking at around 100,000 a year as a recurring cost type thing. But from a standpoint of a router and a port handing off to a campus, that cost may be a lot lower, depending on what the services may be. A CI engineer, so if a regional were to hire a CI engineer and break that down, the grant I think was around 400,000 for a single person for 2 years. So if you take those numbers and you look at a single person or 2, half engineers, if you will, and if you were to say that CI engineer was allocated to a campus, say on average 1 day a week, you divide that salary by and benefits by 5 campuses, you're looking at a $40,000 investment there for a regional to hire a single person, but then offer them out on a routine basis, or on an average of 1 day a week, if you will. So a campus may not need someone full time, but they do want to put the effort in and to take care of that. So just running some quick numbers through a spreadsheet and looking at where a regional can take a look at some of these opportunities. There may be components to break individual services, as well as an FTE down into a part-time or 2 half people or even 2 full-time people to make a team of CI engineers at a regional. So on the same front, managed data transfer nodes, say you have a server that is 100 gig connected, or 40 or 25, that has 20 terabytes of local storage. This may be for a smaller campus that you want to resell, maybe 5 other campuses on that. So you're looking at an annual cost of $2,400 in the very bottom line there for a shared DTN with 4 terabytes for each campus. You're looking at $200 a month for a managed service. So if you break the server down, then add double that cost for support for a sysadmin to manage that at the regional, then you have a managed service there of a data transfer node, as well as paying for part of a sysadmin there that you might be able to break that down. So these are just very quick. I mean, ideally it would be better to sit down and break these down into more of a business plan around these services. But from a regional standpoint and Science DMZ service, there could be a single port off a router connected to a single data transfer node that that could be this simple to Science DMZ, and you've checked a lot of the boxes, and then you can maintain it and perform it well. So for larger campuses that understand this and actually deploy the services themselves, and so be it. But a lot of these sites that are getting some of the small grants or the collaborative grants or even the new compute grants from the CC Star, there may be components of that they may not want to invest for a full-time FTE, but there may be a way to break that down across a number of campuses from a regional standpoint. So this is something that you could obviously work through and kind of see what the numbers look like. So so let's see here. Anything else? Yeah. So that's kind of the first breakdown of the services and the DME perspective. Is there any questions at this point, or would you like me to keep going to the next section? Or
Jen, this is Jen. I think it would be interesting if you wouldn't mind going back to the slide that had your ideas for different types of managed. Yeah, I'm curious for the folks that are representing regional networks on the call. Have any of you implemented or thought about implementing some of these types of services for researchers? Just trying to gauge where you're at in terms of potential upside. And thank you for the cost breakdown, Ken. I thought that was really helpful. In terms of what the return on investment could be for some of these if they're shared across campuses.
Mm-hmm.
Yeah, is anyone doing work yet? Jennifer and I have been diving into that service directory, and I know there's firewall, and monitoring in there, managed routers. But I'm curious how much of that relates to the research. Yeah,
I mean that's the thing where Science DMZ as a service could be a potential for this. So yeah, I'd be kind of curious myself if any regionals are looking at Science DMZ as a service model.
Yeah. Anyone feel like commenting? All right, maybe we'll catch you on the tail end.
No problem. Long weekend.
Yeah. Other questions for Ken or comments so far before he moves on? Okay.
All right. Yeah. Like I said, the idea of the DME is really just getting a baseline of these, what the transfers are happening through your networks, to see that as a standpoint, what the customers are looking at, and then adding a little more into that, you have the regional managed services like this, the different models you can get into, and when you start breaking it down, it becomes very, very inexpensive. In my previous role at Penn State, we broke pretty much every single component of the Science DMZ down into costs, and we had some ports that were $1 a month. We had some ports that were like $8 a month for a 10 gig connection in the data center. So there's a lot of things like that when you aggregate things and you do it from a shared perspective, or you could still, as long as the performance is maintained, there's some ways you can really look into this and really start building out services like this that can scale pretty well. So it doesn't have to be a one-off or one particular customer. There's ways you can build this so that things scale and they're very functional and they can operate them and life cycle, and that's the biggest thing, the sustainability. So another managed service to look into is, once we look at the infrastructure components, which we just discussed, the idea of data portals. This is something where there's a potential to have a front end for data ports, data services that campuses are struggling to implement, depending on whatever science discipline they may be in. But the breakdown of this a lot of times is either it's just set up on a single server, or it's set up, maybe in a lab somewhere that is under someone's desk and that's serving all their data, or there are components around this where there's a single it's using FTP or web lookups to pull the data down, things like that. So the idea around this and scientific portals and science gateways has been out there for a while. This kind of breaks it down into a little bit of what the architecture is going to look like. So this being the traditional case where the network path is what it is behind the campus firewall connected to a regional. You can see this up in the top. You start at the wide area network, give the campus border router coming from the regional, going into the campus firewall, the enterprise network, all the way down to an edge connection where there might be a server or something running from a lab or a research perspective. And then getting into this, so I mean, it works. It works okay, but it doesn't perform very well, and we all know this. So, but some of the pieces there is it's also managed by a researcher or a grad assistant, and that person may be graduating this year, but the project's still going on. So there's going to be some, say, tech debt, if you will, or bit rot, people call it. So anyway, there's going to be life cycle of people that are not maintaining these servers. So again, this could be kicked up to a managed service at some point. So. But getting back to the portal idea is a way of sharing the data out and getting in there. So a lot of times these portals are built around, discovering the data, being able to search for components. You might be able to look up a certain sample or a certain set of data. A lot of times there's a web page to look up some of the data and where to get to it. A lot of times there's different components to it where it may be broken down by individual researchers within the lab. There might be broken down by individual machines or instruments within a lab. I mean, it just depends really who's building this and setting it up. So at the same time, if the instrument's dumping information off of there, there's usually an API access. So I mean, a lot of the workflow and a lot of the pieces, grants that are out there are around workflow of the science and the research side of things, from the instrument to be able to index it, to be able to do the analysis, and then to be able to archive it and then share it out to other people. So there's a lot of grants just built around building scientific workflows, either from an instrument or a certain science. So there's a lot of effort being put into that. So like I said, but from there, if you start breaking this piece down like we did earlier on the network components and the data components of this, can we break this idea down and fit it into the science DMZ? So if you look at the same piece here, what if you were to break this down this way, where you have your border router, or say your managed campus router from the regional standpoint, connected to a switch, or even just straight to a data transfer node there directly, that may have the back end of the data transfer node broken down over here, connected back to the file system. So you would browse the query along the red path. You would browse the web page and be able to search for the data and be able to, query and understand what's going on. You would authenticate, be able to pull the data down. But then the actual data transfer path is the green path. So that's engineered to perform well. And the only thing that's open on that is the data transfer protocols. There's no authentication, there's no web browser, there's no anything to that. So separating out the browsing and the administrative side of everything to the actual data transfer, this is, like I said, a managed service we talked about before with all the other components on that previous list we had. This kind of breaks it down into the actual, how a portal would break down as well. So getting into these pieces here, there's the ability to offer this as a managed service as well, building these portals out. So itself, the idea around the portal is, like I said, breaking it down to make sure it performs well, understanding that the portal side is still just a database, web server, GUI, things like that, to be able to understand what's going on, be able to find your data, your reference data set, or maybe you're sending a sample out to a site they're generating and you need to pull the data back down. Currently, people ship a lot of hard drives or things like that, unfortunately. So this is the idea of being able to put a front end, a performing front end to even an instrument that may be out there at a certain campus or one of your regional connectors. So another component to this is looking at larger scale data sets. So if you were to see a large flow going through your regional network to a campus, you might be able to maybe understand how that individual workflow is broken down. And you maybe ought and engage that campus to be able to see, hey, we'd like to help you make this perform a little bit better. Here's the idea of a portal design, being able to break the science DMZ down, and there's a regional component where you could offer managed services there as well. So the idea a lot of times, again, is around performance. So a lot of times these FTP or web lookups, things like, they manually transfer at megabits per second. But the idea is to get into this to the gigabyte scale, to be able to look at this and be able to see what you can do to pull down larger and larger data sets. I mean, the instruments are just going to get bigger, and the research and the reference data sets are going to get larger. So it's better to have a performing system around this. And like I said, that could be a managed service. Let's see here. So the next component I would say, so the next thing, yeah, we talked about the DME here. Directly on that, there's a link above, but that link actually is not working as of last Friday. So we're working on that right now. So we'll send out the slides and get that working. We upgraded and lost a link somewhere. The other side of it is the portal game. We're working on the portal side of things and actually trying to get that implemented as a Docker container so that you could take the Docker container, deploy it on a system, but then point back to a managed data transfer node. So you could have multiple portals out there that you would offer to many different researchers at a campus that might point back to the managed data transfer node from a regional standpoint. So there could be components there where the Docker container, just you edit in the configuration, you edit what server you should be doing the data transfer path, or the performing server, not the front end, not the search, not the other pieces around that. So that's where you can break this down. And offering the portals out there as a Docker container could tie into more managed services from that standpoint. So if there's anything else you want to get into, we can talk about it sometime. There's a couple emails there. So that's pretty much it. So
Sorry, I just realized I was on mute. I was going to say, thanks, Ken. This is a lot of great information. And I know from the folks that are on the call, many of you are also attending our Quilt CC Star seminar series. And so if you listen in, especially in those areas where areas of any solicitation where regional networks might be able to either be directly involved, or if you're providing being a supporting cast to support your campus institutions, connecting some of these dots, these types of services, that Ken is talking about here, managed research services, could certainly, if you have an interest, tie into some type of proposal with your member institutions. Ken pointed this out as well. Or if that's not, if a CC Star proposal is more than you're looking to bite off, still working with your member institutions, especially your smaller campuses that aren't going to be able to go out and maybe purchase the equipment or have the staff to maintain and manage it. If you can do that across several institutions and make it cost effective, right in the wheelhouse of what the regional networks, that important technical expertise, expert role that all of you play with your member institutions. So I think there's a lot of exciting opportunities in here. And especially, thinking about what's coming up here, if there's a potential for another CC Star solicitation, an opportunity for, some funds and some collaborations to really put these different resources to meaningful use.
Yeah, I think that's one of the vital components of this is a lot of the smaller institutions. I mean, they hear some of these terms and they're just overwhelmed and they're like, I can't take this on. But at a very simple standpoint, it could just be another port on a router connected to a server that is managed centrally. And those components like that are really going to make a huge difference, a huge impact on a smaller campus like that. But from a regional standpoint, that's a way to collaborate and maybe offer this out as a shared service. That from the budgeting spreadsheet we're working on right now to offer out to folks, this is something you could plug in your own numbers, whatever size you want to look at, and you can see quickly how to budget this thing. And even, I think we have a 6 or 7 year budgeting window. You see when things will roll over based on the life cycle, things like that. So there's components there where you can see how long something will last, or if something needs to be refreshed a little more often, you can see how the cost might change. Different pieces like that you look into. But I mean, sometimes you want to go after the larger campuses who are your regional members but sometimes they may already be doing it at a pretty optimal rate, or even maybe it might be need some help too. But a lot of times the smaller sites or the medium sites you're looking at is where they may not have the expertise, or they may just, turn on the network and they're just okay with it running. But this is, again, an opportunity to kind of look and see what else can be managed out there, because a lot of times if they can't figure it out, they'll offer it up to a reseller somewhere else, and they'll just make it, more of an administrative type service, and these may not perform well, things like that. So
one of the reasons, one of the things that gets talked about regularly in this working group is, what are those value-added services that help keep your members, sticky to you, right? That value that you're providing. And on the research side, there's some great ideas in here to consider. Can I ask you, I know that people can reach out to you. You've got your last bullet point here is where if you want to talk DTNs or DMZs or firewalls, do you know where the kind of that living sheet of DTN components is being kept at, if folks are interested in looking at that themselves?
yes, I can share that out after this.
Okay, that would be great too. Thanks.
Yeah, that's something else we'd like to look into, is to try to build with the idea of breaking the portal down and the data transfer layer from a administrative side that's protected behind the firewall and all that, but to the actual data transfer side. We're looking to build reference architectures possibly around what someone may get a certain sequencer on campus. Well, here might be a reference architecture for a sequencer. There might be something for a larger facility. There's different components like that we can break down into these reference architectures. And as long as they're, mapped pretty similar, it doesn't have to be the same brand of server or anything else. But from that standpoint, there are different pieces like that on the reference architectures you can look into, and then, offer these out to individual sites, or, maybe something you would buy one of these servers and then offer it out to a customer. I mean, one of your member connectors, something like that, where if you get into the managed services side of things, you're not only offering the network backhaul, but you're offering these other services that, that sites just may not have the time to put an FDE on, something like that. Even sharing out the components with, sharing a single component multiple times and carve up the hard drive a couple of different ways might be another opportunity as well. So these reference architectures, we're trying to build those out as well as we have more information and see what we get to. So
does that mean you'd have the reference architectures and some of those budget spreadsheets available for folks as tools?
Yeah, the budget spreadsheet is, something I've been working on at my previous role at Penn State, and just try to understand what the pieces are. And we did the presentation last year at the Quilt meeting and I think the PI meeting. We did that. I think it was when we were rotating between groups. The work wasn't really a talk. It was more I can't remember what component that was called, but it was when people would just pick a topic and rotate around the different areas in the hotel to go to different meetings. But we had a sustainability section where you tried to look to see what you're going to do to break down services, or we got the original grant 5 years ago, but now the equipment's getting old. Well, we don't want to go out and ask for it again. Breaking that down kind of shows you that, for example, say you bring in 200,000 a year or 200 million a year in research revenues, but you take the science DMZ and say that was 500,000 and the initial grant anyway. And if you break that down, it's really less than 1% going to be of all research revenue to sustain the science DMZ. So the numbers, when you look at sustaining these research infrastructures, are extremely small in comparison of everything. So we have a reference use case where we broke down, we're actually doing this for a campus right now, and one of the EPOC calls is trying to share with them how to do the budgeting and the planning for this. Is just a side thing. It's really not, a major EPOC function, but it's just something they asked about just because we'd experienced with it before. So, but you can get literally down to every single piece of infrastructure if you really wanted to, and then you could actually add in managed time. So you could add in, 10 or 15% of time to manage a service like that, or on a piece of equipment. What we said at the meeting last year, at the Quilt meeting, was just take your grant and double it and divide by 5 years. That's it. There's your annual ask. That's your new budgeting number. And you see where that should easily sustain that, plus some other services within that. And on the grand scheme of things, from research revenues, it's really pretty small from where it stands. So DTNs are even, even like I said, if you really break down the ScienceDMZ into a single router port and a data transfer node connected to that, it's even much smaller. And once you start maxing out that single 10 gig server, then you can start looking at these bigger services like that. But I mean, larger sites are not even, filling up a 10 gig server at this point. So that's where you can kind of do this very, very at a reasonable cost. I think in the budgeting slide, I had the server we looked up recently was around $2,500 for a 10 gig server with 2 terabytes of local storage. So, that's only $500 a year over 5 years. So, so it's, not that much when you break it down. So,
Yeah.
probably spend more than that at coffee every month, type thing. So, but those kind of components like that, when you break them down and you add them to the grand scheme of things, you can really start looking what your services cost, or at least what the equipment costs, and then you could add in support time to it, depending on what it is.
Yeah.
So there's just, different sustainability models like that,
Yeah.
try to look into and model. But
I'd like to offer other comments or questions for Ken and Epic Services and the resources and the ideas that were presented. There's a lot of information, Ken, I know, in some detail. Would it be possible to get copies of the slides as well?
yes, no problem.
Fabulous. All right, well, thank you so much for putting this together for us today. We appreciate it.
Sure.
And
It was super helpful, Ken. Thank you. I'm from ESnet, and we don't, we don't interface directly with researchers anymore. But I made some notes here because, I mean, it's all about big data, right? It's all about, helping people transfer big data, and it was very helpful, to see the suggestions and the budget breakdown and all of that. I really appreciate it.
Yeah, I mean, this could be any component within your network. I mean, all down to router ports and cards. I mean, doing 5 and 7 year spending plans, things like that. But
yeah,
even the piece here in the middle could be, even for people, you kind of ballpark where they're going to be, and maybe you don't need a full-time FTE for a single site, but you might be able to break them down and offer them up. So
yeah, I keep thinking for telehealth, for hospitals.
Mm-hmm.
And now more than ever, I mean, it was already picking up before COVID. I think now even more, that things are getting transferred, over the network, X-rays, and sometimes even surgery is being done, So it's just coming up fast. I think it's not going to be just for research. It can have different applications.
Mm-hmm. Yeah, different services like that could be modeled down and have individual components down to it, even with certain performance level agreements, like you mentioned, the telehealth or the remote surgery. There may be certain components around that you build up, and you can break those services down. If anything falls below a threshold, then obviously you can adjust accordingly. But there's different areas like that. I mean, the network's connecting everything anymore, so and it's very, very vital.
Yeah.
Ken, this is Ann Zimmerman from ESnet. You were talking about really increasing the throughput, like when you were talking about like 5 gig to doubling it to 10 gig.
Mm-hmm.
Do you have performance? Do you have examples of performance that increased when you did that? Or
yeah, back here on the Petascale project. Where was that at? Yeah, beforehand it was like, they were transferring at single gigabits up to somewhat double gigabits like that. And then when we actually tuned these performances or these endpoints, obviously you see they jump from single gigs to in the double up to like multiples. So you're up in the 20s to 30s to 40s. And these are the big areas that these are larger sites to transfer a petabyte within a day, and that's what we're trying to get to is 15 gigabits a second. Sustained for 24 hours should transfer a petabyte. So if you look at a single 10 gig server transferring data, a lot of times you're not going to have that much data from some of these sites, but you might. the idea of having these and having the DME data to be able to pull that data down should give you a nice baseline from a variety of reference data sets to start from. And then from there, you can say, well, we should be at least at 5 gigabits a second, because you can see here how well these servers can transfer. So if you're even below on a 10 gig server, 5 gigabits a second, it's probably something to look into.
Okay.
A lot of times, I would say, this is just, my own observations, but if you're below a gigabit a second on a 10 gigabit server, then you really need to look at it. If you're between 2.5 to 5, you're doing okay. Between 5 and 8 is kind of like where you should be doing these transfers. But again, it depends on if you're transferring a lot of small files over and over and over. So the data sets are really, it's kind of hard to say you should be at this throughput, because it depends on the data set and how it reads and writes through the entire process. But like I said, on average, around 5 gigabits kind of fits both the larger files as well as a lot of small files type area. So, but yeah, building like a performance level agreement or something like that, where you would have, say you had a dashboard, like a person owner dashboard doing these data transfers on a routine basis. Say your warning threshold is at under 5, say your critical threshold's below 1, something like that. So on a 10 gig server. And like I said, you can see from even the general numbers that I showed later on of the tests we've had so far from the DME, that even the averages are really around 5 or below for everyone. So again, I'd like to break that down to see what servers are more than 10 gigabit, what servers are not, and try to break it down for similar servers. But yeah, there's definitely could be some improvement there. So that's what we'd like to do over the next year. So.
Thank you.
Mm-hmm.
And is it possible to get a list of institutions that have signed up and are participating? I was thinking for at least for the folks on the call, Anne and Kika and others, would it be interesting to see, which of the institutions are actually, I don't know if you've gotten phone calls from them as part of their performance tuning, network tuning, but it might be interesting to know who's got an interest in this, because then you know that they're passing some data that they're wanting to improve on.
Yeah, we can get that data. I think we have a log of all that data at this point. We have the sending, receiving site, and a few other components around that. So yeah, we can get some of that data and share it out.
Great.
But again, this is just really, you see the traffic going through your network and you see your utilization graphs, but this is really taking utilization and looking at performance, not so much how much is going through, but how fast is it going through there. And that's really the key behind all this. So. And we all know how much we love to wait in line for coffee or sit in traffic. So it's the same kind of thing. So
right. Running short on patience these days, right?
Yeah, get there and get it done. So
yeah. Well, this is great stuff. Thank you again so much. Mm-hmm. Yeah. Any final questions? I think everybody knows where to find, Ken and Jason and the team, the EPOC team involved in all of this. And we'll be glad to get those slides out too. But if we can get those participants, I'll just be glad to send it around to this group that's present here. Might be interesting to see, which of your institutions are on that list.
Yeah, and if anyone wants any further details of even like the service modeling and stuff I did previously in my previous role at Penn State, I can sit down and get through that too if you want to see more details. I mean, it was down to every single component, but it's just, I had a finance person say, hey, how are you going to sustain this? I'm like, I don't know. So we went down and I just started breaking every single component down to see what they were going to cost. And then we just rolled it up into service costs. So that's really, out of scope for this initial talk here. But like I said, definitely would share that if you want me to. So.
Yeah, and that's, mentioning that's right in scope for this working group as folks are developing services, that the finance folks are asking that too of, is this going to stand on its own and sustain itself?
Yep.
Yeah.
Understood.
Very good.
Understood.
Yeah, right in the thick of that conversation.
Okay.
All right, well, good. Please stay on. You're welcome to stay on here for the few minutes we have left. We've got, we had a couple of other agenda topics, and one is our services directory. There's some questions that we have for the working group that we can probably shoot out by email instead and just get some feedback again, you know, doing another pass at cataloging some of those, getting some input on how to catalog and describe some of these services. And the other one was related to, you know, the email thread that was started here on market analysis. Corey, I know you mentioned, I think you chimed in too, that this is something that's of interest to IU, but the market analysis for determining service value. I didn't know if we wanted to, we don't have probably enough time for a full-blown conversation, but if we wanted to put this at the top of the agenda for next time, if others were interested in continuing that email thread in person for one of the service working group calls. How do folks feel about that?
That sounds reasonable.
Yeah, you know, if it's of interest, we can. Otherwise, we could just keep it online.
I mean, I obviously would like to do it. I was the one that sent out the original email. You know, I think it'd just be good to know what others have tried to do.
Okay, good. Let's put that.
Don't need to cry about it, Corey.
I'm just so broken up over it.
That's great. And then, you know, we're scheduled to get together in a month from now, but we'll be trying to do some work on the services directory in between that. And also just want to put in a plug, encouraging all of you to join us for our upcoming Quilt Fall member meeting. If you haven't yet, register today so you can be on the list. We're sending out some, you know, bundles of fun and appreciation for our Quilt 20th anniversary this year. If you register by today. Otherwise, registration stays open. So we just would love to see you and have you as part of our general session and breakout discussions there too. Oh, thanks, Corey, for sharing a little bundle of love there too with us. Beautiful. All right, well, Ken, thank you again for the great presentation. We really appreciate that. Lots of great information. Hopefully it gives people some ideas and sparks some conversations within member institutions for the regionals. All right,
Yeah,
and yeah, Ken just put a URL in the chat room there about the Data Mobility Exhibition too to get more information.
Yeah, a working URL. The other one's not working yet.
All right, very good. All right, thanks again, everyone.
Yep.
Bye.
Thanks.